Hey, this is Brett from ISW. Today we have another design process for you, this time for a nightlife build out in Lower Manhattan. I thought this was an interesting space to design the audio for. Typically in Manhattan, there are space constraints, low ceilings, lots of reflective surfaces to avoid, and a whole bunch of neighbors that really hate loud music. This space checks each of those boxes, but we were up to the task. What you won't see in today's design review, but something you should keep in mind, is the time spent interviewing the project stakeholders to understand the functions and features that they've asked for and what's ultimately important to them. The prospect was really looking for sound reproduction, primarily through DJ performances. So that's the content style we're preparing for. They asked for a full sound spectrum system. They also asked us to use techniques to reduce noise traveling upstairs as much as possible. Finally, they were hoping to have their first couple of events within the next month or so. The solution has to be delivered under a tight timeline. With that context, let's get into the design process. When we start this process, ideally, we've already gone through a site survey and we have some type of blueprint. Typically, a full set of drawings, honestly, is really helpful, like using the elevations and the reflected ceiling plan and all that good stuff. We did not get that. So this set of prints had really no usable measurements. We were able to grab some key measurements during the site visit, like the elevation and some of the longer lengths of the room, which is really useful because then we're able to scale that. When we have that PDF, what we then do is we get that into a program like SketchUp, and we're in a 3D environment, which is pretty cool. We have here is a 2-scale 3D model of the space. The ceilings were 9 foot 3 inches tall. There are a number of columns, and there is an HVAC duct running through the middle of the space. And there's a ceiling that's dropped an additional 1 foot 3 inches towards the back here. So these are all some of the space constraints. The client asked for the DJ booth to be located in this area, and they're also hoping to put a stage that may exist in this area. Okay, so getting the design out of SketchUp, and we went ahead and imported this directly into L-Acoustics Soundvision. Hopefully this space looks reminiscent of what you just saw. It's ready for us to go ahead and start configuring the type of performance that we want to achieve, account for the space constraints that we have, and also things like budget. So let's dive in. One of the first things I like to think about is the overall performance that we're looking to achieve. Based on the client interview, knowing the type of crowd that they have and the type of content that will be played there, I went ahead and set expectations at a performance level of up to 100 dBA. And I like to set an appropriate frequency response curve that I'll be targeting. So let's start there. What you can do is you can open up the frequency response curve feature. We can adjust some settings. First thing that I want is a slope of the mid and high frequencies at 100 dB. So I'm going to bring that down from 105, which is standard. And I actually want to increase the curve of the low frequency contour. L-Acoustics has a lot of data and actually they just published a pretty cool new study, which I'll link to in the description below, but they have a preference for low end. This carries quite well into EDM, rock, hip hop, things like that. We're going to boost that low frequency contour up to 15 dB over the mid and high frequencies. Something that I thought about with this design is that I wanted to stay away from most of the infrasonic frequencies because they'll rumble the building so much, and we want to avoid that. The last thing I want to do is tighten up the deviation from our curve down from 5 dB down to 3 dB. 3 dB is hardly perceptible by most humans. And so if we tighten to 3, what we're really targeting here is like a very consistent sound experience, or at least like an average that really falls in line with the target that we're trying to achieve. Now that I'm happy with the settings, let's go ahead and turn on the audience. I added an audience listening height of 5 foot 9 inches. That is the average height that is used when you think about an average person that's standing and where their ears will be. Having been in the space and knowing how it wants to be used, the first thing that I want to create is a stereo images in the central part of this area, which will basically function as a dance floor. When speaking with the client, there was a couple ways that we may want to approach this, and one of them might be a very easy to deploy. Sometimes it's a much easier way for our client to access higher quality gear without so much upfront cost. So that's how we began this process. Thinking about the room and the fact that we have some very reflective ceilings over here and that we have mostly a standing audience, I wanted to use something that had very wide coverage to make sure that everyone was covered since we don't have much height to throw from, but at the same time, not going to be throwing a lot of energy off the ground or off the ceiling. And in the L-Acoustics ecosystem, when I think about a system that's easy to deploy and achieves all those things, every time it's going to be Syva. We've added some Syva left and right here. I've turned off the audience just to give you a better context around how this is deployed. I want to go ahead and turn on our mapping and we'll be able to see how we're doing so far. Here's our dBA coverage with just 2 Syva, one left and one right. And we can see that we have achieved pretty strong coverage. We really don't have many shadows. We're achieving quite a lot of SPL up front, almost 112 dBA. We wouldn't run the system that hot. We'd probably attenuate the entire system by 6 to 9 dB at least, since our target is really only to get to 100 dBA. Let's see in the furthest corners how we're doing. So right here, we're only at about 95 dBA. So what that tells me is that even with these Syva basically performing at their maximum, we're still below or slightly below our performance target in the back of the room. So taking a look at our frequency response, we're doing quite well for most of the probes. But as I mentioned before, we have really way too much SPL in the front of the room. We have people here experiencing, for example, 115 dBA at 4,000 hertz. That's going to be very painful for our friend here in the front right. Let's attenuate that to something more realistic, and then we'll see how the people in the back are feeling. We've attenuated each Syva 12 dB, and what we see here in the frequency response curve is that our closest individuals are right where we want them to be. However, we have lots of different audience members that are well below the pressure level that we need. If we look at the mean, it is well below the bottom tolerance that we've set for ourselves here, which is 97 dBA. What does this tell us? Ultimately, and this is an instinct that of course you have in a room like this with low ceilings, that's going to be chaotic with a lot of people talking, is that we need to have fills or more of a 4-point system. To add our fills, we started by adding 2 additional Syvas, and you can see we have them placed really on opposite sides of the room. They're likely not going to be providing a stereo image, probably mono. And for that reason, we've spread them out a little bit more as the energy will dissipate in the back half of the room. You can tell it's wider area. There's space under the stairs. They may want to have more conversation. Also, spoiler alert, the subwoofers are going to be on this side of the room. So it makes some sense that the fills be spread out more and not in a stereo image. Clearly, we have coverage on the back side. Everything's at minus 12 dB. Let's see how we're doing on the frequency response curve. Okay, so taking a look here, but technically we're even at minus 12 dB, we are in the bottom section of our coverage here, starting from, looks like we start crossing over at about 803 hertz. So we have a good amount of energy happening down there. But what is concerning me is the absence of energy from 100 hertz up to 800 hertz. And a lot of that energy is going to be driven from the Syva low of the Syva. The Syva low is comprised of 2 12-inch transducers, whereas the Syva itself is 9 5-inch transducers, including a waveguide with high frequency elements as well. We want to go ahead and probably add some of that back. And most likely what we do is we'd add a low pass shelf, say maybe at 800 hertz for the Syva, such that they perform more around our target. But that would be something that's done during EQing of the system once it's already set up. At this point, we set it on minus 3 dB for the system to get back that gain that we needed around the 100 hertz or so on. You can see here that we're actually achieving our target curve down from, it looks like 66 hertz up at this point, which is perfect. Beginning somewhere around 400 to maybe 500 hertz, we would likely use a low pass filter on all the Syvas to bring down this excess pressure level that we have here to ensure that we fall within the desired frequency curve. Now that we have our mid and highs, there is something else that I wanted to address. There are plenty of point sources and coaxial loudspeakers that L-Acoustics has on offer that might be a good fit for this relatively small room. However, the reason that we really wanted to stick with Syva for this application is something that we can illustrate in Soundvision. So going back to our mapping, you can see that there are virtually no shadows anywhere in here, that we have pretty solid coverage. If we wanted to go with a simpler point source box as a fill, we wanted to see what that would look like. We'll go ahead and mute those Syvas and hide them. And we're going to add back in some X12s, which is a very capable point source loudspeaker, oftentimes used as a monitor or just a fill. We've used them as main PA, and we could use those as main PA in this scenario as well. So these X12s, when you look at even the website, they're very capable in terms of SBL, 136 dB, which is right up there with Syva. The frequency response is also great. The challenge comes with the directivity in this space constrained room. So while these have a directivity in the horizontal plane of 90 degrees, Syva does 140, which means that they're going to cover a lot more people across the width of the room because the vertical directivity is 60 degrees, and I believe it's symmetrical 30 up, 30 down. There's going to be more energy on the ceiling. We can articulate this in Soundvision. As you can see here, we have our Syvas up front and we've added our X12s in the back, and I've turned on the ceiling, and we should be able to see how much energy is going to be sent up as opposed to the audience where it's needed. We have turned on our mapping, and you can see there's quite a bit of orange hitting the ceiling. There's nearly as much energy going down as there is going up. And that's a concern to me, and one of the reasons that I didn't want to use this. Let's check out what happens when we put Syva back in this position. Boom. So there you go. Significantly less energy is being applied to the ceiling. Right here, we have probably about 115 dB right in front of the loudspeaker. But up here, we're looking at color steps of 6 dB. So we're nearly 18 dB down. What that is going to translate to is a far cleaner sound image. We're going to avoid harsh acoustic reflective surfaces, which would create incidences of delay and indirect sound pressure waves that are reaching the audience's ears because they're hearing not only the loudspeaker directly, but almost immediately thereafter, they're going to hear the reflection from the ceiling, which is then going to hit their ear. That's not going to make anyone happy. It's going to create a fatiguing environment. So that's one of the primary reasons why we chose Syva. After experimenting with X12, while it achieves enough sound pressure level and enough frequency response, it's ultimately going to make the listening experience significantly worse compared to Syva. Now that we have our high frequencies largely taken care of, let's go ahead and add the subwoofers. I prefer to have my subwoofers in one location rather than distributed around the room. I would rather it make logical sense to the attendees that on one side of the room, there's higher energy. On another side, they can escape the peak energy environment. One side of the room is more dance focused, and another is a bit more conversational, a bit of a cool down area. Maybe there's a bar over on that side of the room or a place to sit down and rest. I strongly prefer this, and I think it just makes sense to have it this way versus something that's highly distributed. We stick to a 1-to-1 ratio of 1 low frequency extension to 1 Syva plus Syva low. We used a cluster of 4 KS21, and to clean up the imaging and to reduce the amount of acoustic energy that is immediately being sent to this boundary wall, we went ahead and arranged them in a 3 forward, 1 back cardioid configuration. If you're not familiar with the different subwoofer presets or any of the presets from L-Acoustics, they have an amazing guide. It's like the Bible for working with their system, and it's one of the most frequently used documentation resources. It goes over every preset on every amplifier and every different combination you can think of. Looking at the frequency response from Syva low and thinking also about the way that KS21 sounds, we went ahead and chose a 60 hertz preset, which means that there's going to be a low pass filter for the KS21 at 60 hertz. It's going to attenuate a lot of the energy above that. It's going to really tighten up and allow it to focus on the low frequency extension. Let's take a look at the mapping, and we're going to actually focus on the 25 to 80 hertz. We have a lot of energy capability, a lot more energy than we have in dBA, but that's what we want. We've muted all other sources so we can get the picture of what the subwoofers are doing on their own. We have a super consistent distribution. Soundvision is a free field simulation, so this is not entirely accurate. There are going to be room modes in the space that create interferences. The energy bounces off this wall and connects with this column. It could create a buildup of energy in this back corner or on the back wall, or there could be a null right in the middle of the dance floor. The way to mitigate this is room treatment, things like mineral wool, insulation, very thick bass traps that allow the low frequency energy to dissipate and transform into a little bit of heat rather than continuing to bounce around the room like some kind of insane wave pool that you might find at an amusement park. Let's take a look at the frequency response from our probes. This is what I like to see. We have plenty of low frequency energy. We have more than what we need on average, but not grossly so. We do have one audience member that's getting blasted up front. But remember, humans have a high tolerance for low frequency energy, and I don't like to run the subs at 0 dB if I can help it. It's always better to not push them into clip and blow circuits and stop the music. All that's bad stuff, plus distortion. Let's turn on our mains again and let's see how the overall frequency response is starting to look. I'm pleased with the overall frequency response. Remember, starting at about 500 hertz, we are going to attenuate and add a low pass filter to those Syvas to bring it down and in line with our curve. I love to make cuts. It's much more advantageous to cut sound that you don't need versus boosting it when you don't have enough. One last thing that we want to take care of in this design, now that I'm satisfied with our mains and subs, is going to be our monitors. As I mentioned, there is going to be something of a DJ booth setup here, and we have a pro here that is going to stand in as our DJ. They've been neglected, so it's time to give them some love. For simplicity's sake, and also to ensure that we fall within 4 amplifiers. By the way, the scope for this design that you're seeing here would require 4 LA4X. The rack itself would probably be in the room or very near the room, and we would run the entire signal chain in analog, maybe AES primary and fall back to analog. We probably likely wouldn't be using AVB or any kind of network protocol in an area this small where signal degradation is not going to be of great concern. We have a pair of X8 that would likely be on some type of jam stand mounts, and then we're just going to continue the train rolling. We're going to give the DJ their very own dedicated KS21. We'd actually run these X8s in the X8 monitor preset, which lowers their latency and accounts for the fact that the listening distance is going to be very close and attenuate some of those high frequencies. Taking a look at our full system response, things aren't perfect. We have some nulls, probably some delays, but we're definitely where we're shooting for. We have enough level, which means that we can make cuts needed from there. As I mentioned before, we were going to take a look at not only a rental situation, but also a permanent install. Now, Syva and Syva Low are an amazing system. However, they're quite costly, and they're really meant as a stacked system. There are brackets that allow you to integrate it into a wall, but this isn't really its intended usage. And there is a product that L-Acoustics makes that's very similar to Syva. We began the design by thinking we may not want to use Syva for a permanent install for the reasons mentioned, but maybe we can use its sort of cousin called Soka. This is Soka. Let's put a comparison up. You can see, and these are to scale images, that Soka is a bit more slender. That's because the transducers that comprise its mid-frequency element are 3.5 inches each, whereas Syvas are 5. So Syva really is a bigger, more robust box. Additionally, it's a little bit taller, and it also has greater sound pressure level. I believe by 4 dB. I'll put up the spec sheet comparison here so you can see it. One of the important things about Soka that continues to make it an attractive option for this space is that it has a very wide dispersion in the horizontal plane and very tight in the vertical plane. It's asymmetric. It can be 20 degrees downwards or at a negative angle. And I believe it's flat or 5 degrees in the positive angle. If you work sitting underneath Soka, you're still going to pick up those high frequencies and some of that detail that you might lose if it would just be. We can get started by looking at our dBA mapping for our mains. Things are in pretty good shape here. Performance is more or less where we need it. One thing of note though, is that we are not going to be getting the same amount of output as we had with Syva. Taking a look at Soka's performance here, we actually have really great performance in the lower, middle, and the high frequencies. Beginning at 375 hertz, we are on target. And we don't have way too much level. Like, we're right where we need to be. We're right at the top of the upper limits of this curve. The highest that our average goes is about 103 dBA at 1,838 hertz. And that's only with 2 boxes left and right. We really don't want to have these running at full gain, and then on the other side, the audience isn't really getting what it needs. So I think it does make sense to still retain those fills. We added those fills on opposite sides, much like we did the Syvas. And now we have more high frequency than we are going to need. So again, we're going to be able to use a bit of a shelf there, which is my personal preference. We're crossing our low frequency contour at 220 hertz, which is about 150 hertz lower than we did previously, which is excellent. So far, Soka really looks like a winner. It's also a lot cheaper than Syva. This has me really excited about the prospects of using this design, that the performance is even more in line with what this space benefits from without any real drawbacks. Let's add the subs in. We're going to use the same subwoofers. So we have the same subwoofers here. We're not using cardioid. We could play around with that. But before doing that, there was something that I noticed, and maybe you can tell, but adding these subwoofers in, okay, we have a big problem, and that's right here. That is between 80 hertz and 218 hertz. We have fallen well below our low frequency contour. This really provides a lot of punch in the bass and also a lot of the upper bass frequencies that are going to result in the mix feeling a bit thinner. Sometimes people do like to cut or notch out certain harmonics like 160 hertz or 250 hertz because they can create some muddiness. But to cut out that entire segment is going to leave this feeling boomy. To address this, we went and we looked at the preset guide. What's cool about the preset guide is that we can look up the recommended pairing between Soka and KS21 to see if maybe there is some user error here. When doing so, we stumbled upon something that's very important to know about the Soka enclosure, and that's that it has 3 different presets. Soka in its full range capacity isn't necessarily defined, but when you look on the website, Soka is advertised as a 60 hertz to 20,000 kilohertz box, which sounds great. It sounds like there should be absolutely no gap between 80 hertz and 220 hertz. Why would there be? When you really get into this is when you look at the preset guide, remember that's 60 hertz, you can see that Soka 60 is actually a dedicated preset that extends the low frequency limit. However, the max sound pressure level is reduced by 6 dB, which, depending on who you ask, may be about half the volume. There's an additional preset here, Soka 200, which I believe is meant for SB10i. Let's go back into Soundvision. Let's see if we can get better result with the Soka 60 preset. Something unexpected happened, and that's the Soka 60 preset actually made this worse. It lowered the level overall. Now the crossover has been pushed from 220 hertz out to 402 hertz. So what that means is that everything now from 220 to 400 is now below our desired contour level, and the crossover in the lower limit is still at 79 hertz. Beyond that, we can see that the level has gotten more dramatic, which means that we would have to add more gain to the signal or to the output of the amp, which really, it's not something I want to do. At this moment, I really started questioning that Soka may not be the right solution for this space, despite having so much in common with Syva and how successful Syva was going to be from a temporary perspective. It really turned me off from Soka at this point. Back to the drawing board, what we wanted is something that has pattern control, as we've discussed, something that could reduce the reflections off the ceiling and that could work well and have very strong phase alignment with KS21. That brings me back to the origin story of KS21, and that was developed with the latest ARCs or A series that comes in both the A15 and the A10. Why don't we go back to the basics? Let's couple our KS21 with an A series box. We shouldn't have any of these weird gaps in the frequency response. Let's take a look at A15 versus A10. And the first thing I thought about were actually the size constraints of the space, because here you can see we have A10 focus and we have A15I focus. I stands for install version. The way that we are going to be able to realistically rig and utilize A10 in this space, I think is more realistic. I think A15 is too big. And in fact, you can see here, it's in the wall. It's probably about an entire foot further into the room. And as you can see, it's going to hang lower. It's going to be more in the face of the dance floor attendee. We can take a look at the mechanical differences here. The A10i, 2 boxes, is about 2 feet 5 inches tall, and the depth is 1 foot 6 inch. The A15 is 2 feet 2 inches, so 8 inches deeper and 7 inches taller. Between the additional cost and the size for the space, it seemed like A10 would be the winner here. But there is one important distinction. The A10 has a 10-inch woofer versus the A15 has a 15-inch woofer. The A15 goes down low and naturally pairs well with KS21 with the 60 hertz preset, whereas A10 is actually going to need more sub. The KS21 is going to have to cover an additional octave or so to actually work well and deliver the full frequency spectrum response. It'll keep cost and budget down and work better for the customer, which is most important. We can take a look at our source cut view and get a sense of the coverage. Here's our HVAC duct. Here's the drop ceiling on the back wall. We can take the minimum coverage sort of to about here, and we'll extend our reference point to the middle of the dance floor. This center of our coverage doesn't actually extend all the way to where we would like. However, the upper bounds of the vertical dispersion is taking us all the way to the coverage. So we're getting a 92% coverage here. We could add an additional 5 degrees of angle splay between boxes as we did, and now we have 100% coverage. Something else that we can do is we can actually reduce the sight angle of the top box. So if we were to start at 0, we're really tracking the ceiling. We may want to add more angle back to the second box. This is probably the maximum coverage that we can get for this space. However, I know that we have this HVAC here, which is metal, and I don't see the need to put as much energy into that, knowing that we're going to have fills on the other side. I'm going to settle for a compromise and keep that first box at 2.5 degrees. We're still going to be avoiding the ceiling in great part. To ensure that the coverage is even, I'm going to bring this back up to 5 and leave it there. Something that's really great about the A series box is the pan flex feature. That's the fins that adjust the distribution of the high frequency energy. And when looking at our boxes here on the left, which is where we'll start, we want to avoid hitting this sidewall as much as possible to reduce reflections. I'm going to change it back to its default, which is 110 degrees symmetrically. We have plenty of energy that's going to be sent into these walls, and that's on both sides. What I wanted to do is to close off this side and symmetrically close off the right side. We went ahead and used a 3550 on the left array. And as you can see, that has really closed off the left, which is going to improve the sound imaging for most people in the space. We could close it all the way down to 70 degrees symmetrically, but then the people right in the front would miss more of the detail. After achieving the 90-degree asymmetric coverage and the stereo image that we want with the PA, it was time to think about the fills. So in every design, we've needed fills. There is not enough space to really get the A10i back here. We don't need so much energy. What I thought would make a lot of sense is going to be a distributed array of point sources that can neatly fit within the space. X12s would be unnecessary and they really don't fit very well. There is an install two-way box that has a great frequency response, that has plenty of level, that would nicely fill the space and complement what's happening for the main PA. So what we ended up selecting here were a series of 4 X8Is. These X8Is have been rolled 90 degrees and their sight angle is at minus 20 degrees. We avoid some of the ceiling and focus the energy on the participants. When we go into our mapping here, you'll see that they nicely fill in the areas that were previously green. Let's check in on our frequency response. I like what I'm seeing here. So if you remember when we were looking at Soka, we had a big problem below 220 hertz. We are here at 220 hertz and we have no issues at all the way down to 102 hertz. That is perfect because we're going to bring in subwoofers and we're going to have them functioning up to 100 hertz, and that should marry up perfectly with the system. We're using a cluster of 4 KS21. We could opt to pursue a cardioid or a supercardioid deployment. We're going to keep them in standard mode just to make sure that we have enough before we start getting cute with the acoustics. We have them currently in KS21-100. If we were to pursue A15, we would actually have them running in KS2160. And to give you an idea of what that does to the frequency response, we have a sort of peak crest around 48 hertz with KS2160, and we're at our lowest around about 86 hertz. If we change to KS21-100, you can see that we may lose some of the peak. Our peak now has shifted to 54 hertz, so these will respond a bit towards the punchy side of things versus the infrasonic, but we have a far more consistent experience through our curve, all right? And some other things that we noticed during the design process sometimes, and this is often something you do when you're out in the field and you've actually set the system up, is to mess around with phase and polarity. Overall, the average was slightly better when we had the subs out of polarity. There's some big disparities and issues with the front center. They have a wildly inconsistent frequency response. The person in the center has hit a real null. The person in the back middle is not getting the type of level that they had. We thought that keeping them in polarity was preferable. What should we do for Mr. or Mrs. DJ? A left, right, and a sub are needed. We chose SB18 install versus another KS21i, and we used a pair of X8i point source two-way speakers, a little brother, I suppose, of the X8i. They have a slightly tighter frequency response. They have slightly less output, but because these are a DJ monitor, it's a way to not go overboard with the budget, not use a more powerful loudspeaker than is necessary, but still give a great image for whomever is DJing within the booth and ensure that they get what they need to be able to perform. Yeah, this wraps up the design process for this video. We were able to produce 2 different designs using L-Acoustics, one for a temporary or a weekend style rental that could be set up with a sound engineer and an additional tech, and another system that could be permanently installed. Again, thanks for checking out this video. We really enjoy this process. We want to share it with you all, and there's not enough videos on YouTube of this design process. Playing around with these cool mapping tools allows us to put out a great product with a much higher degree of confidence. We have a lot of preparation that goes into each project, and that helps us do best for our clients and create the best work possible.